So for this one, we're focusing on insertion sort. There are different types of sorting algorithms, which are heap sort, bubble sort, merge sort, binary search, birth search. But here we'll just write an algorithm for insertion sort, and we'll do the rest in the next videos. So to do this, we'll focus on the same example we did last time, where we have a marks in a class. We have students who got 55, 66, 77. So I'm just writing random numbers out of 100 as percentages, basically. So 46, 77, 22, right? So if we have this array of marks 55, 66, 77, we put 22 here, and this is an unsorted array. So using insertion sort to sort this, insertion sort goes to the first index, which is 0, then we take this as a sorted array. Then we jump to the next index, index 1. Let's take this as I. So the first thing we do is we look at I and compare it with I minus 1, which comes here, which is index 0. So if I is less than I minus 1, then we'll switch and put I where I minus 1 was and bring I minus 1 to where I was. So now we'll have this array as a sorted array. See, 22 is less than 55, right? Then we come to index I. If I is less than I minus 1, then we'll sort. But here, since I it's greater than I minus 1, we keep it as it is. So here we have an entire sorted array of 22, 55, and 66. So insertion sort does this throughout the array until we have the final sorted array. So I'll start writing the code. I think it'll be easier to understand as we go on. So our function, we'll just call it insertion sort. And here our inputs are marks, which is the array we gave in marks 22, 55, which is the defined array. So because we'll be playing around through the length of the array, let's just take n and initialize that as the length of the array, marks. Now that we have the length of the array, we'll write our first for loop. So what we do with our first for loop is we say for I, or for any mark within this array, so that means in range I, for I in range n, which is the length of the array. So for I, for every mark within this array, while then we make sure that our I is greater than 0. So index is greater, while I is greater than 0. Since we're starting with 0 and we're comparing every integer from I plus 1, we're comparing every integer here to the one prior to it. So to the one before it, that'll be I minus 1. So I has to be greater than 0. And so what we do is, and we compare that an integer or marks at index I. So we say if marks at index I at this here, for say for instance 55. So this one, let me just put 12, 13 here. So we look at index I here at index 1. Let's say this is I. We compare it with I minus 1, which is 22, right? So we'll say marks at index I, say I is index 1. If that is less than, say marks at index I minus 1. If it's less than index I minus 1, then we can say let's switch the two. So now we apply our insertion sort. We say marks index I marks index I minus 1. So what we're doing now is switching both indexes 13 and 22 in our arrays. Marks I minus 1 marks I. Perfect. So after switching this, remember we want to sort the entire array, so we'll keep deducting 1 from I until we get to the first minimum or the least mark in our array. So we'll say minus 1. So we keep doing this until we get to the first number. So after this is sorted, then we can return return the sorted array of marks. Right? Let's go through it one more time. So we have our function insertion sort, which takes in the marks, and then we reinitialize our n as the length of the marks. So we say for I within this range, the range of n, that's the length of this array, while I is greater than 0, so we make sure the index is greater than 0, so it's not at index 0, so that will be 1 upwards, 1 plus 2 or 2, 3, 4. Then we say max at index I, so that means max at index I. If max at index I is less than the prior mark, that max I minus 1, then we can switch this to and have it sorted. Then we keep doing this until we're done. So to run this, we'll take our array of marks. We'll take our array of marks and call our function insertion sort. We call our function. So from here we should be able to get our sorted array. Perfect. So you see now you have a sorted array, even with repeating integers 22, 22, we have them sorted. So we had 22 on our array at index n minus 1. So now we have everything sorted. So this proves that our code does work.